Mainframe. There, that's actually where the name comes from, because the box was the frame where they put all the components in. This one's great, because it happens sometimes when people mistype the word in emails. This one is a picture of main in a frame, right? This one is so close, it's very close. For this talk, I started using Copilot to draw some of my, you'll see the slides as you see some of the stupid pictures it drew. But I asked it, I wrote the exact same prompt. Without looking it up, draw me a picture of a mainframe. And these are the 4 options Copilot gave me. I think it fixated on the word looking it up, because it drew a bunch of faces. The very interesting thing, this is the only one that I generated that actually spelled the word right. Right? Typically, like if you do any AI, if you mess with any of the AI arts, this looks like a word, right? Because it's imagining what things look like. All right, so who am I? I go by Soldier of Fortran. My name is Phil Young. I do mainframe cybersecurity research and mainframe pen testing. I've been doing that for 15 years. Before that, I was an IT auditor at Visa, and I became a mainframe hacker, mostly out of spite. It's not really a joke. It happened because I was in a meeting, and they told me that their 3 pillars of security were compliance, identity access management, and you can't just go and buy the operating system at Best Buy. And I'm like, none of those are pillars. And then I was so mad at that, I went to my hotel room, found the operating system on the Pirate Bay, allegedly, and then may or may not have figured out how to emulate it, wrote a guide about it, and then posted that on Pastebin. And then went in Monday morning, not only is it cheaper than Windows, it's free, and some hacker wrote a guide on how to do it. So, and I was chipped away at their pillars. So, right now, I am the director of mainframe pen testing at NetSpy. So I do this full time. I break into you're going to hear a bunch of war stories as I get through the tools and go through what I do during a mainframe pen test, right? We cover the whole stack. We cover all the applications, web servers, all that stuff. Okay, so one of the questions I get often is like, I want to do more mainframe cybersecurity stuff at my company, but I can't find any documentation or any articles about mainframe breaches or mainframe ransomware, right? So, show of hands, who thinks there have been mainframe breaches? Okay, first, I wouldn't be up here if it was like, no, right? Like, come on. So yes, of course there's been mainframe breaches, right? Like, that's an obvious question. Now, the fun part, show of hand, can I tell you about them? Yes or no? Yes, put your hand up if you think I can talk to you about them. No, I cannot. The Mainframe Hacker Society, it's like very rumor-based. IBM keeps a real tight fist on the mainframe security. They don't issue CVEs. I know this because I have tried. I actually went to MITRE, submitted a CVE for a network job entry. It would allow you to enumerate the O host. I'm getting super technical mainframey stuff, but they forwarded my CVE to IBM, and IBM just replied, no. So even if it's a vulnerability, they won't give you one. The most they will do is when you have a patch, they will put the CVSS score in it sometimes. So like some of the tools that I've written all of a sudden don't work, and we can't figure out what patch fixed it, and because it's just like software update, and that's the patch notes, right? So, however, if you really want to read about one, there was one that was heavily publicized in Sweden. This is about a decade ago. A hacker who used to run the Pirate Bay, he was able to breach a government mainframe, and their investigation is fantastic. The best part is they wrote 2 reports, one in English and one in Swedish. And in the English one would have half the script, like say the top half of a script that the attacker used. And then in the English version, or the English version would have the top half, and then the Swedish version would have the bottom half. And so I gave a talk in Sweden, and I was telling that story, and they go, the 2 dudes who wrote the reports were like, I thought we agreed on the opposite. Like they both, it was just like mixed messages. So, okay, So that's, look, if you really want to look it up, it's all on WikiLeaks. It's super cool. They go into really great detail about what this attacker did, and like they were in there for years. All right, so it's really in depth. It's the only sort of public acknowledgement of a mainframe breach. In fact, the government of Denmark forced IBM to release CVEs. There was an exploit, a privilege escalation exploit in the Unix kernel, and the patch is for NetView. That's how they patched it. The patch notes are for NetView, a different product, because they can't admit that there are problems. So, okay, you might notice a terminal here, all right? So that, you're gonna see things like this. So this is AI generated, and I will put the prompt on the screen as we see these pictures, right? And they get worse as we go throughout the talk. They get more insane as we go. Because, anyways, so this talk is about this, right? This is ZVM, right? It's the VM. This is TN3270. We will be exploring, trust me, we'll be exploring TN3270. This is what this talk's about. It's about this. This is what a mainframe looks like. Has anyone seen one in a data center? Except for just like right now. Yeah, yeah, yeah. So they used to be the size of like an industrial fridge. They used to be huge. And now they're this tiny, it's this box right here. It's just this. Just this. The rest of it's just hard disks and virtual tapes and stuff. Right? It's not this huge behemoth. Now, I'm not going to talk about this. Anybody know why I'm not talking about this? No, I mean, lots of companies still use mainframes. Anyone know like Kirkland? Anybody know what they use? Who has a Costco membership? You ever seen that? They use the green screen in the store, right? Does anybody know what's behind that green screen? Anybody want to guess? Absolutely, it is not a mainframe. That is insulting. Dave, I think you already know.
I thought it was AS400.
It is absolutely AS400. If you look carefully, in the back it might be hard to see, but you can see it like System BYA400. Costco is all AS400s. AS400s are like baby mainframes, and I don't touch them, okay? That's not what this talk is all about, the big iron, right? In this picture, this is one of my favorite. Where's the mainframe in this picture? It is not the whole picture. Anybody want to guess? That thing, could you be more specific? The thing that says IBM, yes. So that is the mainframe itself, okay? And that remember when I said that picture, that person drew like a frame? The term mainframe comes from all the computing components, the CPUs, the cooling, all that, it hangs off of a frame. And they just started calling it, that's the main frame, right? The rest is just I/O, okay? So here we have like a card reader and a terminal. And card readers were huge. Think, like, you have tape drives and crap in the back, right? Those are expensive. Paper is cheap. That's why everything was cards. Yes? Blinking lights. It just tells, like, so there's a bunch of registers, and those are probably, like, they don't have that anymore, but it's the registers, like what's going on. Because if you have a crash, you can just look at the panel and see like, oh, in register 12, which was supposed to be X, was something else, right? And then there's a bunch of dials down here, so you set like, so the fun thing about mainframes is you have to tell it how to boot. It's all like bespoke, handwritten, locally sourced system programming. So you have to tell it like, hey, we're gonna boot off of this hard drive, we're gonna launch, and then you're gonna find the config files on this hard drive, right? You have to tell it that, there's no automation. Everything is batch driven. So when you look at this photo here, let's go back a few slides so I can show you the card reader. This is how you interfaced with a mainframe. This is how you interface with mainframes today. It's not, this is gone, this is long gone, but the way you interface with it is still the same. So everything was batch driven. Think of like headless things. Think of like GitHub Actions. Anyone here use GitHub Actions? Or like Docker containers, anything that has like a headless thing, you just sort of fire and forget, right? There's no interactivity. That's the mainframe, right? Everything is done in what's called batch, right? When you boot the operating system, you tell it the hard drive to look at, and the first thing it does is it launches Jez2, which is what drives batch processing, right? When you log into the mainframe through a terminal, it kicks off a job, right? Everything is a job. So that's all managed through job control language. Think of it like the worst scripting language you've ever seen, okay? That's not a joke. In fact, the guy who invented it, he gave a talk at the Computer History Museum, and even he was like, it sucks. We're sorry. But we had no choice. Like, we had to make something. So this is what it looks like. It is fun. It is literally just a scripting language. That's it. It's just a scripting language. It looks super complicated, but it's just, like, so the first line, that's like your shebang in like a bash script or a Python script, whatever, right? That's your first line. That is called the job card. Every line in here, remember I said like cards, it's still a thing? Every line in here is a virtual card in your stack, right? They don't call it that anymore, but that's the history of the platform dating back to the 60s, right? So it's really not that complicated. So the first thing is, actually, can you do me a favor? Can you lower the lights? Because a bunch of my screenshots are black, and it's going to be hard to see. It's a little washed out. I'm just trying to make it easier. I know what I'm doing, but I figure it's better for everyone here to be able to see this stuff. So when we look at like JCL, it's really just we're running a program, right? This is the program we're going to execute. So think of this like if I was running, I don't know, like netcat, right? And then you pass it a bunch of flags, or it expects environment variables to be set up. Same freaking thing. So you have the program you're going to run, then you have the environment variables. That is not what they're called, but I know no one here knows what they're actually called, and I'm dumbing it down, right? So if you get really interested about, yes, do you know what they're called? No. Data definitions. So, but really, you have to think of them conceptually as environment variables, right? They are things the program expects to exist for it to run. And if you don't declare them here, then it won't run. It'll say, you didn't put sysTS in. I don't know what you want me to do, right? It'll error out. So, and then down here you can see I'm running TSO commands, right? So this program, ikjeft01, which rolls off the tongue, runs TSO commands in batch, right? So this is how you run like shell commands in batch. Why the name is crazy? The product, so think back to the 60s. You have multiple, like you can't put documentation on the machine because hard drives are stupid expensive. And you'll only have 8 characters to identify a product. So the first 3 characters identify what class of product it is, so you can go look up in that guide, right? So IKJ is TSO, right? BPX is Unix. There's a whole bunch. Okay, so you submit jobs. Again, they are non-interactive. So you submit it, and then you get your results. It took me, I want to say it took me 5 years to get over this, right? It took me about 5 years of doing stuff on the mainframe until I was like, I guess I should really just learn how to really like write JCL, right? And once you get good at it and you use it, then you're like, this is the greatest, this is the best. Because everything's reusable, right? This is JCL I use on engagements for mapping out a whole bunch of stuff. I'm not going to walk through all these because that would be a whole talk on its own. But this is a job that's going to map out using SDSF a whole bunch of configuration items and things that I can use on an engagement and then dig into later, right? So I've already submitted this job on my mainframe, and now we're going to look at the output in my mainframe that my employer gave me, right? So this is how you view the output. It goes to like a virtual printer, and you can browse the output. So you can see here, or not in the back, I guess, but you can see here I've got all this stuff, right? All this information here is now running. Oh, thank you. So now you have all this information I just submit the job, and a couple of seconds later I get all this stuff back, right? I have longer running jobs that I'll talk about when I get into enumeration. Time sharing option, that's the shell. So this is the shell that you run. Oh, that's perfect, thank you. Is that better for folks? Yeah, much better, okay. So, time sharing option. Anybody know why it's called option? No? I'm not gonna ask, like, it's optional. It was like, remember the terminal? That terminal was the master console. So time sharing was optional and was not included in the operating system. and you paid for it as an optional product add-on because you had terminals that people would use. Now it's just included as part of the operating system. But things, legacy doesn't change the name. So time sharing option, it's that red ready prompt. It is the interactive way that you interact with the mainframe. This is where I spend most of my time during pen tests when I'm doing stuff, unless I'm doing, like even submitting jobs through TSO and stuff. You can use it to run scripts. So like here you can see a little cactus I made up for a REXX script. REXX is great. You can call, you don't execute programs, you call compiled programs. It took me, when I first started doing this, it took me 2 hours to figure that out. Okay, yes, Dave?
Do you have the nice command in time sharing?
No, there's no nice anything about this operating system. It's by engineers for engineers. Hope you like reading. So you access files with ISPF, you submit jobs, you profile, so there's a whole bunch of stuff you do in TSO. REXX is the best. REXX is a scripting language, very popular in well-known operating systems like ZOS, ZVM, OS2, and Amiga, right? That's who uses REXX. It's a very niche community. But it lets you do a whole bunch of stuff. It lets you create sockets. It lets you profile. In fact, a lot of my tools, we will rapid prototype something in REXX to see if it's feasible, and then rewrite it in assembly because it's slow as hell, right? Because it's an interpreted language. But it's very powerful. The thing that it doesn't have is arrays or dictionaries or anything like modern, right? But it's good enough. So, like I said, we rapid prototype in REXX, then we write the actual tool in assembly. I hate assembly, but what's that? I get why. Yeah, it sucks. The other thing I don't like about it is like whenever I write assembly, I feel like I'm finally looking through the looking glass, and then you realize like everything's just a giant calculator, right? Because you have to hand write your for loops, you have to hand write everything. It super sucks. And also you have to manage your memory, and yes, go ahead. Yes. So the question was, is there any memory segmentation? Yes, each user gets their own virtual memory stack. There are ways, if you can get APF authorized, to see other people's memory, and there's a tool being worked on I can't talk about that may or may not let you see things that other people are doing. But yes, so like as a regular user, you are isolated to your, and regular processes not running authorized, you are isolated to your sort of own virtual memory stack. So I write my tools in assembly. They're very fast. So for example, I have a tool called Nmap I'll talk about later. In REXX, it took hours to run, and in assembly, it takes 10 minutes. Right? So huge difference and huge speed up in time. But it's the opposite. To write it in REXX took me 10 minutes. To write in assembly took me 3 weeks. So little bit of a time spent there, but huge savings on pen tests. RACF, so yes, question? You'll see later when I'm talking about the tools, you'll see why. Because there's specific like calls and macros I'm using that are not available in the other programming languages. Yes, another question in the back. Oh, okay, I love this interactivity, by the way. Don't worry about it. I will cram through slides quickly in the end if more people have questions. Okay, so RACF is the security product. There are 3 security products, which is the other reason why we use assembly. There's RACF, there's Top Secret, and ACF2. RACF is by far the market leader with like 80 to 90% of the market. The way it works is the operating system goes to what's called a SAF router in the OS and says, hey, is my user allowed to access this file or this resource? And then the router is set up, configured to talk to one of those 3, whatever one you installed, and then it responds back and says yes or no. And it's all stored in a database, but it's not really a database because you can't access it in any meaningful way. It's just called the RACF database. You have to use TSO commands to do any kind of work with the RACF database, right? It's not like a SQL database or anything like that you would be used to. It was written, again, it was written in the 70s. So the file system is flat. There are no directories, there's no hierarchy, there is nothing, right? It is a flat file system. Max file name length is 44 characters, but it has to be broken up into 8 alphanumeric chunks followed by a period until you hit 44 characters, right? So that's why you end up getting like very weird spelling of like, you'll see, vowels just disappear because you don't have the space, right? Folders. So folders, I'm going to call them folders. People call them libraries. Really what it is it's a flat file that the header of the flat file has pointers, and it just divides up the flat file into chunks. So it's still a flat file, but it's been sort of like logically divided up so you can store files in it like a folder, okay? And they do that because you get it, there's reasons. Yes, question? I have no idea. I don't touch AS400s. That's not a joke. That's I don't like. This looks similar. They call stuff libraries. Yes. Yeah, because AS400 was like, oh, people can't afford this big one. What if we made a smaller one with a different operating system and the skills don't translate? It's very classic IBM. So it also runs Unix. AS400s also run Unix. So z/OS runs Unix. It drives the networking stack, but it also comes with everything you expect a POSIX compliant Unix to have. I'm being very careful. Unix. It's not Linux. Doesn't come with a bunch of the commands you expect it to. grep doesn't work the way you expect it to, but it's there. I use it to write code and stuff. Look, it's just Unix. It's just regular Unix. Like I'm not going to let that whole gift play. APF authorized, right? So think of a setuid program in Linux, right, or Unix, right? You assign it, or a directory, you assign it, setuid, so that when the program runs, it can run as whatever UID it's set to. Now imagine instead of that, it was a folder, and anything in that folder inherited those permissions. And then imagine if it, instead of being setuid, it was kernel. So anything you put in these folders runs as the same authorization as the kernel does, essentially ring 0, right? So yes, question? Yes. It's why I'm here today. So this is what we target in every single freaking pen test. We are trying to get APF authorized. If we can, it is game over and I can do anything I want on the system because I am in what's called on the mainframe key 0. Key 0 lets me edit anything in memory, and then from there you can kind of just do whatever you want, right? And there's reasons why we'll get into in a bit. Okay, let's talk about how we actually do the pen test. Also, I want to point out, I put a typo. There's no space between hand drawn. That's why I think it added a hand for some reason to this picture. So good old AI art. All right. When we do, so we typically start with a network pen test. Network pen tests are just network pen tests. It's not super special, right? You need an IP address, and that's all I need to start going after the system, right? Think of all the tools that you would use in a traditional network pen test or web app pen test. It's the same. It's just a computer, right? Yes, the architecture is different. Yes, the file system is different. But at the network level, it's literally just a computer, no different than any, except for when we talk about SNA in a second. But, okay, so myth number 1 that I have to dispel all the time. Will port scanning a mainframe cause it to crash? Show of hands for yes. I called it a myth, guys, come on. Show of hands for no, right? Yeah, no, if it was, it's the year 2024. If Nmap was crashing like Bank of America's mainframes, that would be a major frickin' problem, right? Like, you can't, oh, sorry, ATMs are down because some like compliance dude ran Nmap, right? Like, come on, all right? So no, port scans haven't brought down a mainframe since the 90s. It's a big old myth. If you want, if we have time, I can tell you why that happened later, or just come find me after and explain why they crashed mainframes in the past. I just use Nmap, right? Why do I use Nmap? Because I'm the one that wrote all the tooling for Nmap. I would say 10 years ago, 15 years ago, Nmap had no idea what to do with the mainframe. It would tell you the wrong operating system version. It'd be like, oh, this port is Telnet, and that's it, right? I rewrote the probe files to include a bunch of mainframe stuff, and because I don't like myself very much, I wrote a Lua TN3270 emulator for Nmap, okay? And the whole library, and then on top of that, a whole bunch of scripts to use that library. And if that interests you, I'm teaching a workshop tomorrow about Nmap scripting and how to write scripts and profiles, and it's not mainframe based at all. So if you're like, fuck this, that's fine. Come to the workshop tomorrow, there's no mainframes. Okay, so now this is what, when you Nmap a mainframe, this is what it looks like today. This is literally yesterday, I was working on my slides yesterday. So this is what it looks like now, okay? I'm gonna walk you through all of these as we go through. So first things first, we're gonna look at this. This is TN3270, or as I like to call it, the gateway to the mainframe, right? Because really, when you connect to TN3270, you're connecting to a different type of network, right? So now you're going from TCP/IP to SNA, and there's like week-long trainings about SNA, so I'm not gonna get into specifics, but essentially, now that I'm in here, it's like a text adventure game, and I'm trying to figure out what applications you're running by trying to connect to them. So how do we scan SNA networks, you might be wondering? Well, you do it by hand, right? So this is my mainframe, and for those in the back, it's down here, I'm typing, that's supposed to happen. You type log on, then the application ID you want to connect to, and then you guess a name. And if it takes you somewhere, you found an application. If it disconnected you, then you didn't, right? Now, obviously those are two like simple examples, but that sucks doing by hand. So instead we just use Nmap. Nmap A has a brute force library, so I don't have to do any threading myself, because I hate it. The other thing is I can use all the facility, and the other thing I like using Nmap is it comes to you. You all, if you're running Kali, you can do this right now, right? You don't have to go to my GitHub. It's readily available for you right now. So here you can see I'm running the VTAM. VTAM is what runs the SNA server. I'm using VTAM enum, and you can see we found a valid application ID TSO here. This is a dumb example. Typically you'll find dozens, right? And you'll find multiple different setups. So you might find Kix regions, and there's like a whole bunch, some of them labeled prod, some labeled dev, right? And you can find things like the dev one might not be as locked down as the prod one, but they're all running on a production mainframe. From here, we would typically just I can enumerate all the users using TSO, especially through SNA. There's a setting to not allow you to enumerate users, but very rarely have people turned it on. So I have a script that will let you enumerate the entire user space, and then you know all the users that can use TSO. And then from there, we typically just do like a password spray, like one password, like month at year will get you in if there's enough users, right? So like Walmart, or like a company with a large call center will have thousands of people using their mainframe. They all need mainframe IDs, and a bunch of them will pick bad passwords. Okay, so that's TN3270. Let's talk about like a regular ass web server, right? This is just a regular web server running Apache, right? I literally installed this on Monday, right? So it's just the most recent version of Apache. So this actually happened on an engagement where I found this web server, and I was like, okay, cool. What do you do when you find a web server? You run nicto, right? And then it found default creds set up. Why? Like, you have to go out of your way to set up default creds, but I guess they did. And then from there, I was in the system, and I was able to like run shell commands. And you just use Metasploit, legit just use Metasploit or MSF Venom to create the WAR file, and then you have a reverse shell through Tomcat on a mainframe. Like, it's not, that's the thing, like, yeah, it's foreign, but at the network layer, these kind of attacks just work, right? So, and mainframe for a long time was excluded from pen tests because people were like, oh, you can't touch it because you'll bring it down. But also people were like, well, we don't want someone who doesn't know what they're doing touching it. Everyone here should be able to hack a web app, right? Like, it's not that different, except for this. So this one is different. This is called Shadow Web, and for people who I used to work for might recognize it. But I'm being vague and not specific. So what's nice about Shadow Web is it comes with, by default, it's a REXX web server, and by default, it comes with the ability to browse the source files for your web server. Cool. The way it does that is through this. This is like abbreviated and is not the exact one, but something similar to this, where this looks, to me, for me, This looks very familiar. Couple of characters and then a dot and then and it's an uppercase. That looks like a data set to me. That looks like a member within that data set. So what am I going to do with that? Well, first I'm going to try, well, I know what exists on every mainframe. There is a thing called sys1.samplib. That's they put all the samples of things you would do. That always exists on every mainframe, right? So I just downloaded that file. And then from there, I was like, well, maybe I can download the RACF database. And then once I download it, you can crack the RACF database with John the Ripper. And then you just have and especially if they're only using 8 characters and they haven't enabled AES encryption on the passwords, you can crack every single user with an AWS cracking rig within a day. By the end of the day, you have every single user, right? I didn't do that because I found a bunch of admin users on my MacBook, and then I didn't bother cracking the rest. Okay, so that's the web server. Oh, that was web servers, right? And I don't run Shadow Web on my lab because you have to pay for it, and I'm cheap. Last one, a sticker to whoever knows what this port does. It's not VMnet. I'm going to walk, because you answer some questions, I'll give you a sticker already. I'm going to take a little walk, take a break. Anyone want to guess? You can't even look it up. It's so esoteric. No one's going to get this. Anyone want to yell? There's no wrong answers. Someone yell out an answer. I already mentioned it once. It's not Telnet. Really? Has anyone? No, it has nothing to do with web. I already mentioned it when I was talking about jobs. It's so there are a bunch of wrong answers, it turns out. What if I say the first word is network? The second word is job. It's okay. It's network job entry. All right, this is the port. In fact, this is something we literally discovered this week. Yeah, you were close, Dave. I'll give you a sticker. We discovered this week in the mainframe hacker community. You used to be able to send a probe, like a very specific packet. It's in the Nmap profile if you want to look at it. And then it would come back and tell you, no, that's bad. And now it just resets the socket. So IBM has prevented us from even probing the port. But I know what the defaults are, and no one changes the defaults, so who cares? It's 175 and 2252. That's network job entry, right? Network job entry, it is amazing. I've written an entire Python library about it. So network job entry works like this. I'm in a mainframe in Orlando, and I need to talk to a mainframe in Phoenix. All of my JCL is on the mainframe in Orlando, but the data I need lives on a different mainframe. So in the job card, I say, don't run my job here, run my job on that other mainframe. You don't need to pass a username or password. You don't need to provide credentials because the nodes are trusted. So one node is trusted. So in part of the packet, there's a header in the packet that is the username of the user that submitted it. And if that username exists on the target node, it runs as that user. And what we find is over time, companies consolidate. As the mainframes become more powerful, they consolidate down from 5 to 3. But they don't delete those trusted nodes in the settings. So then we connect with this Python script and pretend to be one of those trusted nodes, and now I can run as any user, even if that user is locked. Okay? That's network job entry. It's amazing. So how do we test it, though? Like, how do we find the nodes and all that stuff? You're never going to guess it. We use Nmap, right? We run an Nmap script, and this is how we find. So these are called the R host and the O host. These would be the things you're trying to figure out, because this would be the system you're attacking. I don't have the time, because I got like 23 minutes left, to get into the details, but if you really want to get a deep dive on network job entry, I gave a talk at Wild West Hackenfest that's literally in the bits and bytes of network job entry. Like, it gets down really deep, very technical. I also have an article in POC or GTFO that goes into detail about the protocol as well. So if you really want to learn about network job entry, you can go read those. Okay, so we're in now, right? Like eventually we get in, right? It's just a matter of time, right? Sometimes on red team engagements we just say, what was their Windows password, and then that works, right? Like eventually we get in. It's not hard to break into mainframes. But once we're in, that doesn't mean we necessarily can do anything, right? So what do we do next? Who here has their OSCP? A person. Great, I'm so glad I have that cert. Really great. OSCP, the rule is you enumerate, 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 right? Like you have to gather information. So we have a whole bunch of things to enumerate the system. Someone asked earlier, why do we write in assembly, like why not use C or Java? I'll talk about Java later. Because we use things like the very clearly named IGGCSI00 and rack route. So IGCCSI, that's the catalog interface. And then rack route is how we check access. In fact, this is, over here, this is the rack route call. So all we're doing is saying, show me all the files that exist on the file system, and show me my user's access rights to those files. That's what's happening. So here, for example, this is what the output looks like, right? From here, what I'm looking for are things like data sets named JCL-lib, data sets with the word rackf in them, data sets with the word HTTP or FTP. Since it's batch-driven, people use JCL to FTP files around. They put their creds in the JCL. So if I can read those files, this has happened. You can get their username and password, and they didn't even know those files were world readable, right? Because it's not as easy to tell like it is in Unix. If you look at this carefully, you can see my janky shell script that I use in Unix because I tried to compile TrufflePig using Rust. There's a Rust compiler for ZOS. The compiler crashed while I was trying to compile TrufflePig. So we use this janky. It's one of the tools I'm working on now. I'm working on a Java tool to do this instead that will consume TrufflePig. Anyone knows what TrufflePig does? TrufflePig, you get a bunch of YAML files with regex, and then you check files that you have access to if that regex exists, and it finds passwords and keys and all kinds of stuff, right? I want it to run on the mainframe, but that's not going to happen. So I have to write it myself. So because I have access to data sets, I check what I have access to, right? The other thing we have is a REXX script, and this one is written in REXX because it was easier, but also because it doesn't need to be assembly. This is a REXX script that enumerates a whole bunch of things in the operating system. Remember that first picture where like hard disks and stuff? Hard disks are expensive from like a cost perspective, but they're also expensive from an I/O perspective. And the mainframe is all about speed. So it puts everything in memory. And this script reads everything from memory because it's all there. Some of it documented, some of it not. So for example, look, if I'm all imposter syndrome-y on an engagement on my first day and I'm like, why am I doing this? And I'm gonna get fired. I will run this script with the sec argument, and I will get this, and I will instantly have my first finding because it will say there's no password rules defined, or the password rules suck, and I can go and say, hey, your password rules are bad, right? That's easy wins for me, and then my confidence starts to go up, and then by the end of the second day, I've got APF authorized, and I've owned the system, right? But is it easy? Like every mainframe I've been on, the password settings have been like, yeah, I guess it can be like 5 to 8 characters, but you don't have to have any special characters. And we don't save the history. Right? Typically, to get this information, by the way, you would need to have admin rights to even, but it's all in memory. It's just not documented. Yes? Yes. But it's called walking the control blocks. Well, you'll see another example of that when I talk about the privesc. Okay, so that's all the TSO side of enumeration, right? What about, and we're going to talk about APF enumeration later. What about Unix? Has anyone used linps? Right? Yeah, I tried to run it. Someone told me like, oh no, it totally works on Unix too. It doesn't have to be run on Linux, and it does. Let me tell you, it did not. I ran this on my mainframe, and it was like, no. And like all the graphics were all messed up, and it just didn't work. If anyone wants to talk to me later about, rewriting linps, and pushing that up to their repo so that it supports mainframes, let me know. But if you're like a shell programmer. But I wrote my own called OMVS enum. It's like linenum. It's in fact almost copy and paste based on linenum, and then I added a whole bunch of mainframey things to it. The shells that come with Unix are binsh and tcsh. That's the two shells you get. You can install bash, which I have on my environment, but that's the two environments you get. And they are, like you can't even, on binsh, you can't even press the up arrow, and you can't, like if you typo something, you can't press the left arrow. You just have to like Control C and retype it. Yeah, it's super painful. So again, this script maps out your access. I've used this successfully. I found on an engagement a script that had credentials in it because it was doing like a call to another web server to do something in an API, and it had creds in it, and I used those creds, and that application had access to APF authorized libraries, and then I owned the mainframe, right? And I found it only because, and that system was so locked down, I was so stressed out by day 3, and then I found this file, and I was like, oh, thank God, right? So, you know, always look in Unix. I call it the gateway drug to mainframe hacking because everyone knows how to use Linux, right? So, you know, we check for other things too. So, like all the files, everything's mounted, and those are data sets that are mounted. And if you have write access to those data sets, you can change the bit of the, like at the bit level for the file system, and maybe make it set UID 0. Or maybe make it APF authorized by editing the actual bits in the files that are mounted, right? So there's all kinds of fun tricks we can do on the mainframe in the Unix side. This is what it looks like when you run this script. It goes for pages and pages. Like there's not enough space here. It would be like down to the door if we let it run. But it tells you all kinds of information about the system. In fact, I have an engagement coming up that's just Unix. Someone's like, nah, we don't want to look at the rest of the operating system, just Unix. I'm like, but I can't not look at the rest of the operating system. Anyways, so yes, so Unix is fun. You could probably do a whole engagement. Okay, next myth. There's only 2 myths. I started this presentation like, I'm gonna have so many myths. There's really just 2 big myths. Buffer overflows aren't possible on the mainframe, right? Who here has heard that? Or believe, yeah, thank you. It was true, not because you couldn't do them, but because no one had come along with the ability to do them, right? In 2020, this myth was shattered by Jake LaBelle. Jake LaBelle is a cybersecurity researcher based out of the UK. He gave an amazing talk on buffer overflows at DEF CON on ZOS. I strongly recommend you go watch it. It turns out there were a bunch of APF authorized programs that had overflowable arguments from the command line. So you just type a command and then overflow the buffer, and now you're APF authorized, right? And this had been around for decades. And we had been told, in the mainframe community, you were told, buffer overflows are impossible. That's why this operating system is safer. And it turns out, no. Yes? The idea was that so there's no stack on the mainframe. The registers are different. There's no return pointer. So people thought like, well, because we don't have those things, but you still, when you write a program, it still has to know how to go back to where it came from. So you still have to have some kind of return pointer. You're just responsible for storing it. And it turns out there's something called the language environment, and everyone uses register 13 to store the return pointer. And if you can overwrite register 13, which you can in certain cases, then you can control where you're going to go on the stack, and then it just becomes about finding where you need to go, right? And if that was interesting, that was a great segue, thank you. If that's interesting to you, we taught a workshop at DEF CON about mainframe buffer overflows. We start with a very simple C program. We move to an assembly program that's overflowable. Then we move to a remote code execution. We teach you how to write shell code. This is a self-paced Docker container. It runs the mainframe in your container. The course is all at a wiki. If you want to learn about JCL and writing mainframe buffer overflows, please, it's all freely available. You can run it. And if you get stuck, which you will, feel free to reach out to me. I will gladly help anyone who is interested in doing this, because we definitely need more researchers in this space. So that's buffer overflows. I'm not going to talk about specifics, specific ones, because that's too dangerous, but it is possible, and we do check for it. Like, I check for all the ones I know about. That's the first thing I check when I get on the box. It's like, do these exist? Oh, no, they're patched. Okay. Right? Okay, so last one is access to APF authorized programs. APF authorized, like, again, we said, if I can get here, I can get to key 0. So we have an assembly script, we have an assembly program that will check your access rights. It uses rack route. The reason we use assembly again is because rack route is what we call ESM agnostic. So it checks RACF, ACF2, or top secret with one command instead of me having to program them all and figure out what we're doing. And it's also fast as hell, right? So here's an example. And you can't prevent people from running a rack route macro. You can prevent people from running RACF commands, but you can't stop someone from checking their permissions with assembly. So here I'm looking for things like, so update or alter, right? So those are the two. If I see that on a pen test, I get very excited, and then I run downstairs because I work from home, and I tell my wife about it, and she's like, cool, can you pick the kids up from school today? And I say, I guess, and then I go back upstairs, and then I text like a friend, and they're way more enthused, right? So from here, we do this. So a sticker, again, to someone who can tell me what this does. I'll tell you what, I'll give a sticker to except for you, you've already guessed. I'll give a sticker to a person who just guesses. I'm gonna give you a sticker anyways because you've been very participatory, so don't worry about it. I mean, you can guess. That's absolutely what it's doing. Holy shit. So, come on up, get a sticker, come on. So here's what's happening here, Remember I talked about walking the control blocks earlier? In memory, so like I said, there you go. Oh, thank you. So, for those who didn't hear, you said I really like this presentation. Making it clear. So, in memory is your access rights. Why? Because imagine it's the 70s, and every call center person is logging in at the same time, and all of a sudden they're checking access to files, and that's all happening at like 9 a.m. If it had to go to disk every time it did that, the system would slow down to a crawl, like tapes and stuff, right? Disks were very slow. So instead, your access rights, for the most part, like the important ones at least, are in memory. In RACF, the concept of special and operations, special is root, special and operations is essentially root on a mainframe. That is controlled by 2 bits in memory, not bytes, bits. And if we can change those bits, then we can become super users. Only problem is that region of memory is in key 0, which means we as users are usually in key 8. We cannot change it. Unless we're APF authorized, that's what this mode key 0 does, is it changes us into key 0, and this literally finds that bit and changes those bits. And how we use that is typically we will put it in this JCL as an inline program, but there's no room on the slide. There's 3 steps to this job. The first step is we assemble and link the exploit, the privesc. Then we run it, and then because now we're super users and it's ephemeral, right? Because it's only in our current session's memory, we then run this command, which makes it permanent. This is altering the user, give them system special in the database itself. After this, I log off, log back in, now I am root on the box, okay? You could run this from the TSO command line, but again, it's ephemeral. So here's what I'm doing, right? Essentially what's happening in memory is this, right? Changing those bits in assembly, but then you have to do it to keep it. Yes? That is a, so the question was, is this something that blue teams would get alerted to? It absolutely is today. Well, okay, blue teams maybe not. That's a whole other can of worms. But like mainframes are, like socks on the mainframe, about 10 years behind the rest of everything else. So nowadays, if you do this, there's an alert that will show up on the master console that says, this person is not special in the database, but somehow they're special. that's a problem. You need to look into it. Does anybody follow up on those errors? Not in my experience. Okay, like I've been on pen tests where I've done just exactly this, and they're like, how'd you get system special? I'm like, well, I had access to API authors. Like, how come we didn't find out? Like, there was an alert on your console. I saw it because I was the admin. Yes?
Is there any way to get that alert like out to the socket so we have to walk up?
Yes, there is a bunch of tools. I can talk after because I got 7 minutes left and I still got to go through data exfiltration. But again, this tool is like, look, I don't expect you to remember how to write all this assembly and shit. There's a REXX script that'll do it for you, written by a hacker named Ayub. You can just go download it and run it. Please don't hack mainframes unless you have permission though, because you will get in a metric ton of shit if you do. Just from experience. So, data exfiltration, right? This one's my favorite. This one, exfiltration is what the AI says. Data exfiltration is stupid easy on the mainframe because it has a whole bunch of tools for moving things off the mainframe. You can use FTP, SCP, but there is a problem using all these things. Does anybody know why there's a problem moving things off the mainframe? Dave? No. It's way wrong. Yes? No, it has nothing to do with that. It's because the mainframe is EBCDIC, not ASCII. So, everything does it differently. Every single one is like, sometimes it's binary, sometimes it translates. It's up to you to figure it out. So here's a handy chart. FTP, you can do both. SFTP only does binary. SCP only does translation, right? There's like, you just have to know these things. How do we, so this is a fun one. I am pushing for people, and I'm gonna make this offer here. If you know like how to write Java or C, you could write a C2 proxy for the mainframe, because in my experience, mainframes typically have a port or 5 that are allowed to talk just to the internet straight without going through any proxies. Why? Because that's how someone set it up 30 years ago, and no one wants to change it because they don't know what it does, right? So how do we find those ports? On AWS, I run Egress Buster. Does anyone use Egress Buster? It's super cool. It opens up every port. And then the only problem is Egress Buster comes with a Python script to run on the local host, except we don't have Python on the mainframe. Like it exists. I run Python on my mainframe, but it's not really installed anywhere. So we have to write our own port checker. Well, the problem is we can't do it in REXX, we can't do it in C, and we can't do it in assembly because the timeout, that we can control the timeout, the smallest we can get is seconds. 1 second times 65,000 is a lot of hours, right? And that's gonna take forever to check every port. But thankfully, a gentleman by the name of Sir Kix-a-Lot, who couldn't be here, goes by Owen, he figured out that in Java, we can use the old legacy style sockets that allows you to declare it in milliseconds, and then we basically do a SYN flood from there, and we can check every single port in seconds. This is what it looks like. You run the tool in Java, and then after that, you look in your console in your cloud, and you get a whole bunch of ports that are open, and again, I get easy findings in my report. But here's the key. We were talking about log and monitoring earlier. If you can do this, and you have an account on the mainframe, you can probably run a C2 proxy through the mainframe and no one's gonna look at it, right? Oh, this workstation's talking to the mainframe, cool. This mainframe's talking to some host in the cloud, I guess that's okay, we don't know. Because the SOC doesn't know, they call up someone on the mainframe side, they go, we don't know, we're not the firewall team, call the firewall team, right? So it's untapped goldmine if you start using this. I'm not saying to do that, but it'd be cool if someone did. From here, I've used all these. I've used all kinds of stuff to move stuff off the mainframe. Typically, I like to do it encrypted because I'm moving bad things off, like REXX databases, but you can use whatever you want to move it off once you find that port. That's it. Like we got 3 minutes left. I typically don't leave time for questions because I don't get good questions. But this audience had some great questions, so I really appreciate it. If you have any questions, or if you're, look, I'm up here advocating because the community for mainframe hackers is very small. There's like a dozen of us. There's like tens of us. So if this is interesting to you, if this is something that you're like, wow, I've never even thought about getting into this, please reach out. it's way easier now to get into mainframe hacking than it was 15 years ago. There's guides, there's whole YouTube channels. So if you're interested in this, please reach out to me. I'll be happy to help set you up and get you working on this platform. And thank you for having me here today at CactusCon. Are there any questions? Real quick, I got 1 minute. But I want the other person to have time to. Any questions? Wow. Thank you, everybody.